Okay, we're in section 10.2. We're talking about quadratic equations. A quadratic equation is an equation of the form ax squared plus bx plus c equals 0. A quadratic function would be a function of the form f of x equal ax squared plus bx plus c. A, b, and c are real numbers. A can't be 0. Okay, there's a couple of problems at the end of this section where you're going to be working with a quadratic function. So let's take a look at like problem 10 here. Says that a rock is thrown upward from the top of a building that is 160 feet tall with an initial velocity of 48 feet per second. The distance, h, in feet of the rock from the ground after t seconds is given by the function h of t. Okay, part A, how high is the rock from the ground after 1 second? Well, t is the time in seconds, so I would just plug in that number into the function and then simplify. So that's what I've done. If t is 1, I've got negative 16 plus 32 plus 128. You get 144 feet then would be the height of the rock from the ground at exactly 1 second after it was thrown. Part B, after how many seconds does the rock strike the ground? Okay, well, h is the height, so the rock would be on the ground when the height is 0, which means that I'd want to set the function equal to 0 and then solve this for t. Let me do that now. So I'm going to begin by getting all the terms onto the left. That way that leading squared term is a positive, which makes it easier for factoring. So actually 16 will go into these other two numbers evenly. So let me actually make the numbers a bit nicer here by dividing both sides by 16. 16 t squared over 16 is t squared. 32 t over 16 is 2t. 128 over 16 is 8. And that makes the numbers nicer, like I said. Now this equation will factor. Remember, when it comes to solving a quadratic, think factoring first. So this will factor. Okay, t minus 4 times t plus 2 would be the factorization there. And when you set these equal to 0, you get t equal 4 or t equal negative 2. Now t is the time in seconds. Time can't be negative. That doesn't make any sense for what we're doing here, right? So it looks like it would take 4 seconds for the rock to return to the ground then. Problem 11 is the last one here. It says that a golf ball is launched at an initial velocity of 88 feet per second from a platform that is 95 feet high. The distance, h, which is in feet, of the ball from the ground after t seconds is given by the function h of t. Okay, part A. When will the golf ball be at a height of 175 feet above the ground? Give the answer to the nearest hundredth of a second. Okay, so if we need to use the calculator, we'll keep that in mind. H is the height, so I'd want to set the height equal to 175 and then solve for t. So that's what I've done. Okay, and actually I'm going to move everything to the left. That way that leading squared term is a positive for me, which makes it easier for if I'm able to factor. So I've add 16t squared to both sides, subtract 88t from both sides, and then subtract 95 from both sides. 175 minus 95 is 80. And again, I can make the numbers nicer. 16 won't go into these three numbers evenly, but 8 will. So I'm going to divide by 8 on both sides. And by the way, look for those times where you can make the numbers nicer than what they currently are. Okay? I'll have students look at this and then just try to, they'll go right into factoring. That's making the problem more difficult than it needs to be, especially if it's not going to factor nicely. So try to make the numbers easier than what they are, or nicer than if you see that. Now, this equation won't factor nicely, actually. No matter what we do with the arrangement and the guessing and checking, we're not going to be able to swing negative 11t in the middle when we FOIL this back. Okay, so our next best option then at this point is to use the quadratic formula. I mentioned in the previous video how if you're given the option, think factoring first, and then if you've easily ruled that out, use the quadratic formula second. Okay, don't use the completing the square method second, because the quadratic formula comes directly from completing the square, right? So why go through that procedure again if somebody has already done that for us and created a general formula for us to use? Now, I would still like you to know all the methods, including completing the square. That's why I showed them to you. You will see them on the assignments, okay? But I would also add that, while completing the square is not a go-to option for, solving a quadratic equation, since we use factoring or the quadratic formula, completing the square is actually an important, necessary thing to know in other math problems. Okay, like there's other math problems that you guys will see in college algebra and even beyond that also, where the only way that you can do the problem is to know the completing the square procedure. If you don't know completing the square, there is no way to do the problem. Okay, so something else to keep in mind. It is still an important method to know. So anyway, I'm using the quadratic formula here. I want the opposite of b, which is 11, plus or minus b squared, negative 11 squared is 121, minus 4 times a is 2, times c is 10, and this is all over 2a, 2 times 2 is 4 in the denominator. And then I'd want to simplify. Okay, 4 times 2 is 8, times 10 is 80. 121 minus 80 is 41. The square root of 41 doesn't simplify nicely, but I don't think I really care about that because they wanted us to give our answer to the nearest hundredth of a second. So at this point, I would say let's go to the calculator and type in our numbers here, and we'll round to the nearest 2 digits. So here's how you do that on the TI-30 model. Okay, we want the square root of 41.0. I want to see what this looks like in a decimal form here. And, okay, I get that number. Plus 11 is that number. Okay, and then divided by 4 give me 4.35 if I go nearest 2 digits. Okay, and then I'd type in the minus situation also. In this model here, I'll just do the minus situation in this one. You can say 11 minus the square root of 41, hit enter, and divided by 4 is 1.15 if we go nearest 2 digits. Okay, so now I'm going to keep both of those numbers. Okay, in other words, for this problem, there's going to be 2 times where the rock, or the golf ball, excuse me, will be at exactly 175 feet above the ground. Once on the way up, as after 1.15 seconds have gone by. Okay, now the rock will continue to go up. It'll reach a peak and then begin falling back to earth. It'll cross the 175-foot marker for the second time after 4.35 seconds have gone by, and that would be on the way down. Okay, so there's 2 different times that I want to keep here. I don't want to throw one away or something like that, like I did in this last problem. Only reason why I throw this number away is because time can't be negative, right? But there's 2 different times then when the golf ball will be at 175 feet above the ground. Okay, part B, how long will it take for the golf ball to strike the ground? Well, h is the height, and so if it's on the ground, you'd have a height of 0, right? So I'd want to set the function equal to 0 and then solve for t. The first thing, I've moved all the terms to the other side, or you could think about it as multiplying both sides by -1. That's the same thing. That way that leading squared term is a positive for me, which will make it easier, in a factoring situation. I can't make the numbers nicer than what they currently are. So I think that, this would be a great example to just go right to the quadratic formula. Like there's lots of factors for 16 and lots of factors for 95 especially, okay? So rather than, using a lot of guessing and checking and hoping that it factor, why don't we just go to the formula here, okay? So we want the opposite of b, which is 88 plus or minus the square root of b squared. 88 squared is 7,744. And then minus 4 times a is 16, times c is negative 95. And this is all over 2a, 2 times 16 is 32. Okay, so now at this point, I would go to the calculator. 4 times 16 times 95 is 6,080. Okay, now I'm going to be adding that, since I'm subtracting a negative, I'll be adding 7,744, I think, was it? Yeah. Okay, and I'm getting 13,824. So then take the square root of that number, and then I'm going to add 88, okay, and then divide by 32. Okay, and I get 6.42 seconds. In the subtraction case, okay, I'll just use this one here. I'll clear that out. So we want to take negative the square root. The reason why it's a negative is because I'm using the minus situation now. The square root of 13,824, I'll say 0.0, okay, enter, and then plus 88, and then divided by 32. And I get negative 0.92. Time can't be negative, right? So we can throw away that number. That doesn't make any sense for what we're doing. And it looks like after roughly 6.42 seconds have gone by, the golf ball will be back on the ground. By the way, before we did this problem at all, we could have recognized that we're going to have a time that is more than 4.35 seconds, right? Because at 4.35 seconds, the golf ball is at 175 feet above the ground. Okay, when is it on the ground? It's going to be after that time, right? And that's exactly what happened there. So, all right, be sure that you know the quadratic formula. As I mentioned earlier, it will come up a lot actually. Okay, and it's just worth knowing. And be sure to look at the homework problems here that are on page 793. Do the odd numbered problems listed.